This robot has got a 7 billion parameter vision language model running on device on this robot. This is probably the ChatGPT moment of robotics, literally because there is a large language model, specifically speaking vision language action model, running on board within the robot itself. This is a company called Figure, and they've launched a new robot, and in this video we're going to talk about how this robot actually works. It's a humanoid, technically speaking. It's a robot in the shape of human, and this is the same company that just a couple of weeks back decided to end their contract with OpenAI. So this company is supposed to be one of the leading robotics company. It's building humanoids. It's trying to make the robots so that consumers can use it, not just for military purpose. So the new model that they've released is called Helix. This is a vision language action model. I mean, what does it mean? It's a simple vision language model. It takes any of the vision language model that we have got, like Quen or the Llama vision Lava model. So it takes any of these models and then use their information to make the robot take any action. Like, for example, if you tell me, hey, Abdul robot, take the mouse on the table. I mean, human is not going to talk like that. Then my duty is to first use my two systems. They've got two systems. One is my system 1 and the second one is the system 2. So first I'm going to use the system 2, which is the 7 billion parameter vision language model, and then figure out where on this particular table I've got a mouse. Okay. So first of all, I need to understand that this is about computer mouse, and that is exactly why they're using the vision language model, so that they don't have to teach the robot how to do this. Second, once I identify that there is mouse here, I have to have the motor skills, the dexterity to go pick up the mouse and then use it. So this is why they've got a second system, which is an 80 million transformer model. This model is going to control the robot. So there are two different models, but both are deep neural network model. The first one, this is the system 2, which is to process everything that is around you, which is the vision language model. They said it's an open weight vision language model. They did not mention what it is, but I guess that it could be something like Quen, especially given that they've decided to end their contract or partnership collaboration with OpenAI. It's very clear that they're going on with open source models to do this. The second thing is an 80 million parameter model. They call it a fast reactive visual-motor policy that basically translates whatever the understanding from the system 2 is into precise robotic actions at 200 hertz. So that is the speed at which it operates. It's very fascinating to see the kind of things that this robot can do when you compare the existing approaches, how robotics is done.
Yeah.
Can I see everything?
Yeah.
Okay. Wow. I'll really just do hangover first.
Yeah. Be careful of the egocentric camera.
Oh yeah.
Yeah, you can use. Yeah.
I need to pay attention that there's a camera.
Yeah.
The first thing is somebody might be controlling the robot and then try to teach the robot exact steps. Okay, if you were to make a coffee, so if you were to teach a robot how to make a coffee, they would have a coffee machine. They would do this couple of times and then the robot actually learns how to make a coffee. Or if you have to slice the tomatoes, then you would do the same thing. Or if you have to teach the robot how to take the mouse, pick up the mouse, press it, roll it, all these things, humans literally teach the robot. And this is biggest block according to them. Hence, it's very hard to build generalist humanoids. So to avoid this completely, they thought, okay, if I have vision language models that have a very good understanding of the world that we have got, why don't I use that? That is exactly what they're trying to do. So they have got the speed and generalization here. So Helix matches the speed of the specialized single task behavioral cloning policies while generalizing zero shot to thousands of novel test objects. So you don't have to go separately teach the same thing for keyboard. You don't have to go separately teach that for microphone. So you can easily generalize it. Scalability, Helix directly outputs continuous control of high dimension action spaces, avoiding complex action tokenization schemes used in prior VLAs, the other VLA approaches, VLA vision language action, which have shown some success in low dimensional control setups like binarized parallel grippers. They're giving an example, but face challenges with high dimensional humanoid robots. So it can basically scale up. Architectural simplicity, it's just like two systems, system 1, system 2. The system 2 is an open source, open weight vision language model VLM, and the system 1 is something that they've trained themselves, a simple transformer based visual motor policy. There is a separation of concern, and they're saying that they have decoupled S1 and S2, system 1 and system 2. This basically helps them. It's typically what we do in computer programming. We have got modularity. It helps them improve one system while not touching another system, improve another system while not touching one system. So it can run separately on each system without the constraints of finding a unified observation space or action representation. So they've gone into the architecture. So system 2 is a vision language model, and system 2 basically takes the information from there and then uses all the information. So basically they are projecting them into the vision language embedding space, and system 1 picks up directly from there. So system 1 is an 80 million parameter cross attention encoder decoder transformer. So an encoder decoder transformer is very similar like what you have got in BERT, but a cross attention encoder decoder transformer could be something like a read anchor. So it's a simple neural network architecture that handles the low level control, relies on a fully convolutional multi-scale vision, which is the VLM that we have got in the backend. So how does it work in a simple language? If you go tell the robot, pick up the butter and hand it over to the robot on your left. Once you have this particular thing, the same at the same time the robot state goes into the model, so it knows where the finger positions are, it knows the joint angles and everything. Now it goes to system 2, which is going to figure out where you have got a butter. So I don't know if I said peanut butter. So it's going to figure out where it has got butter, and it is going to do that calculation at 7 to 9 hertz, and then in the latent space where they're not getting the instruction out, in the latent space it goes to the new transformer model, and that is going to pick up and then control the robot different actions. It's going to pick it up and then give it to it. It's very amazing to see. So first of all, as a disclaimer, we do not know if these videos are sped up, so they're just saying what is happening with these robots, but we have no clue if the video is sped up or like how long it's been edited, how much cherry picked. I mean, who would have thought that somebody is going to sell Boston Dynamics after all the demos? So you never know what's happening with this robotics company. But here in this particular case, it looks very polished. It looks amazing. The finger control is amazing. So I hope this is the working demo, not just some computer simulation, 3D modeling, Blender kind of stuff. But also we do not know what is the speed at which it is operating in real life and all the information. But either way, this is pretty interesting. You can see a bunch of demos where the robot is trying to pick up something like a very precise coordination. There are a bunch of tasks this robot is doing, and in fact, like it is playing with it is picking up the dancing cactus, which it's a kid's toy, and a bunch of other things. So the robot is really good with handling a thing, and all you have to say is pick up X, like something that is available, and then do it. Very interesting. We still do not know exactly why they ended the OpenAI collaboration, but I think we might have kind of like an idea here, because they decided, it seems that they might have decided that all they need is small language model, a small vision language model, not some latency prone OpenAI model where they have to always have internet. In this case, it can work without internet, which is quite amazing. So deep neural networks are actually going inside the soul of robotics, and it is something that people have been expecting for quite a while, and here we are, figure Helix. Let me know what you think about it. See you in another video. Happy prompting.